Okay, so absolute value x, let's sketch this graph. Doing this with the grade 11s right now. Okay, a piecewise defined function, f at x. This function is defined to be the negative of x when x is less than 0, and just x itself when x is bigger than or equal to 0. Okay, what is the derivative at 0? What is f prime at x? Well, a piecewise defined function has a piecewise defined derivative. And when x is less than 0, the derivative is -1. When x is greater than 0, the derivative is +1. What's the derivative when x is equal to 0? The slope of the tangent line to the curve at this point. Unique slope. It doesn't exist. Why? Because the left-hand limit, and a derivative just is a limit, doesn't equal the right-hand limit. So f prime at 0 does not exist. So that is one of our necessary conditions for perhaps finding an absolute max or min. And in fact, in this case, this is the absolute min. It is at 0, 0. Okay, so when we find those places where our derivative is 0 or non-existent, we call those critical numbers. So a critical number of a function is a number, an x value. It's in the domain of the function, and either of these things happen. The derivative is 0 or the derivative doesn't exist. So just like in these two examples, the derivative was 0, the derivative doesn't exist. So it gives us a possible reason to suspect that we have a max or a min. So it is necessary, but not sufficient. Okay, over the page, let's do a few examples.